go.
Hi everybody, welcome back. We are ready to start our last chapter of the year. Are you so excited? This is chapter 5. All right, the thing about chapter 5 is we're going to start talking about these things called fundamental identities today. A couple of them you already know, a couple you don't, so don't stress out about that. There's a little bit more background information in your book on pages 443 and 444, but basically the chapter is really about those who are going on in mathematics, because college math is pretty theoretical and pretty hard and very abstract.
And all about proofs.
And all about proofs.
You remember proofs?
So we're shifting from solving the problems to theory, to proof.
Right now they're groaning, you know that, right?
Yeah, you can groan, that's fine. The cool part is
I can hear 'em.
we like this stuff.
Yep.
So
we're weird though.
Yeah. Some of you like it too, but it's okay, you don't have to admit it.
You can.
We're looking at how the functions, the trig functions, are related to each other, okay? So the first thing you need to know is, what's this identity thing? Well, an identity is simply a math sentence, and it's basically a truth statement. It's true for all the values for each side of the equation, okay? Remember geometry? We talked about postulates, we talked about theorems. Same thing, only now that we're in trig, we call them identities, okay? There's some that you already know. You know the reciprocals, do you not?
I do.
Okay, what do you know, Mr. Lucky, about cosecant?
It's the reciprocal of sine.
Okay, and so we're not going to go through all 6 of these here, but recognize that they are reciprocals.
And the way you write a reciprocal is just 1 over something.
Absolutely. Just put it underneath of the 1, okay? And the same pairs goes together. We learn the reciprocals more this way, where we started with the sine, the cosine, or the tangent. You do also want to be able to go backwards from the cosecant back to the sine, okay? You've got to go forwards and backwards.
That's going to be important.
It will. Quotient identities. Now, we're all used to tangent being y divided by x, but tangent is also sine over cosine. So it's important that you kind of start getting sine over cosine in your brain. And that means if we flip it over, cotangent would be?
Cosine over sine.
Alrighty. So, we already know these identities. Are there some others? And there are. So Mr. Leckie, who just loves the unit circle, is going to help us take a look there.
All right, so all those identities on the last page, you mentioned geometry. I don't know how much you remember your geometry class, but if you didn't learn those theorems and those postulates and definitions,
it got really hard.
Proofs were really hard. In fact, lots of people leave it blank. Leaving these blank will mean you probably get a 0 on the test, because it's pretty much everything on the test, isn't it?
Yeah, definitely.
So you have to learn them, and the more that you understand them, the more that you have them in your brain, the easier they're going to be to access. So you have the basic ones we had before. Now let's talk about some new ones, okay? We're going to start with a unit circle. Unit circle means our radius is 1 on our circle. And we'd like to relate an equation to x and y. Well, if our point here is xy, then how far is this distance here?
Well, that's the x side, so that's x.
So that's x. And we've got our right angle here. And how long is this side then?
That one's y.
That's y. And what kind of shape do we have?
We have a right triangle.
And so what do we know about the relationship between the sides of a right triangle?
The sides. So a squared plus b squared equals c squared. How about
Absolutely.
X squared plus y squared is 1?
1 squared is 1. That's right.
Perfect.
All right. Now, and when we did the unit circle, we learned earlier that the sine of the angle inside of this triangle here was always what value?
It was y.
It was y.
It was actually y over 1, which is y.
And the cosine is?
X.
X. And so if sine is y and cosine is x, all we're going to do is take these things and plug them into our equation of the Pythagorean theorem.
Gotcha. So that would be sine squared? No,
So
cosine squared.
the first one is x squared, so that's cosine of theta squared plus
sine of theta squared.
sine of theta squared, and it equals 1.
Okay.
And the way we're going to write this is when we square a trig function, we're going to write it as cosine squared of theta plus sine squared of theta is 1.
So you're not squaring a cosine, you're squaring a cosine of theta.
Correct. You're taking the cosine. If you type it into your calculator, you actually have to type it in this way, where you actually type in the cosine and then put a big parentheses around it and square the whole thing. So
Okay, now how's that going to help us with trig? So sine squared plus cosine squared is 1 all
it's
the time?
always 1.
Okay.
Every time you see a cosine squared plus a sine squared of theta, you're going to throw in a 1 instead. You're just going to, isn't 1 simpler than cosine squared plus sine squared?
Much simpler.
Much simpler. All right, well, we got other stuff going on here.
We do.
These are called Pythagorean identities because they come straight from that Pythagorean theorem.
Okay, and that was a little too much fun. So again, we're looking for relationships between the trig functions themselves. So we're going to do something kind of funny here, and we're going to take this equation, and I'm going to divide each piece of this equation. We're going to divide by a cosine squared. Now, why am I doing that? Oh, just for fun.
Just 'cause.
Just because I wanted to know what would happen. Okay, if I divide by a cosine squared divided by a cosine squared would be?
1.
And a sine squared divided by a cosine squared?
Well, sine over cosine is going to give me a tangent, so sine squared over cosine squared, is that tangent squared?
It is tangent squared.
Awesome.
And then 1 divided by a cosine?
Is secant.
So it must be a secant of theta squared. Now you'll hear us when we're talking, a lot of times we say sine or tangent or cosine. We don't say the angle. It is super duper important that you actually write the angle. And 9 times out of 10 it's going to be a variable, a theta, an x, an alpha, a beta, pick
Or
a
whatever
letter.
that symbol is that you've got written on the board.
That was the board. Okay, I'm going to pretty this up a little bit for Mr. Lecky, who's picking on me. And if I can tuck in my squared on my sine and cosine, I can tuck it in on my tangent. So it's going to look like this.
So how are we supposed to memorize this?
Oh, we got to memorize. Oh, but you have Mrs. Cofield, the queen of corny. So let's go. We're going to call this I, because the 1 looks kind of like an I. Tan, as in get a suntan, prom's coming, in a second. Which is really funny when I say it, because I don't really tan in a second. I really burn in a second. But you probably tan in a second.
I can tan in a second.
So here's a
but they
little
don't wanna see
mnemonic to help remember 1 plus tangent squared equals secant squared. Okay, well, you divided by cosine squared, right?
that. Yep.
What else could we divide by?
Why not sine squared?
Oh, that sounds like fun.
There's one of those in the problem.
Let's divide by the sine squared of theta. Okay? So again, back to this original. Cosine squared divided by sine squared.
Cotangent squared.
That's a cotangent squared. I'm going to go ahead and skip to this notation. And a sine squared divided by a sine squared would be?
1.
1. And a 1 divided by a sine squared would be?
Cosecant squared.
You know I started to do that too. Excuse me. Pardon me. Not cosecant, but cosecant squared. Okay.
Yay.
If you want to, again, to remember it, here's a little trick. The order doesn't matter when we add, so I'm going to switch these around just a little bit. And I'm going to get this. And again, here's a little way to remember I, because there's a 1. Slept on a cot. Didn't have a bed. On
That
a
sucks.
cot in Colorado Springs, Colorado.
And for those of you watching this video outside of the city,
It doesn't work. You got to create your own.
or just deal with it.
Or memorize that when you visit Colorado Springs,
You can sleep in a cot too.
yeah, and come visit us. Okay,
That's
so
what camping is. It's called practicing being homeless.
aren't you supposed to sleep on the ground when you camp?
I'm going to sleep in my bed at my house. All right. So how many identities do we have on this paper we have to memorize?
3 Pythagorean identities. This one is the most important. It's very easy to remember because cosine is x and sine is y. Okay, and the other 2 are simply just dividing, or I tan in a second, or I slept on a cot in Colorado Springs, Colorado. It's actually a cot squared. Okay, couple more relationships. If you had FST, you will remember these. Let's take a little right triangle over here, and we're going to call this side C, and I think we called, what did we call? I don't remember. This one A,
Call it anything you
and
want.
this one B. Okay, so we've got 3 angles in there. What's the relationship between this angle theta and this angle up here?
Well, the angles in a triangle have to add up to 180.
Yes, they do.
We already have a 90-degree angle, so
Yes, we
the
do.
angle B must be 90 minus theta.
Very good. And I'm not going to use degrees, I'm going to use radians. So how about pi over 2 minus theta? That's a
Okay.
theta. I promise. It's a theta. Okay, if you remember from our geometry notation, the side across from the angle, we're going to use a lowercase letter for. So that would be C, and this one would be B, and this one over here is going to be A. All right, so we need to look at the relationship between these 2 angles. So let's just say what if. Instead of talking about the sine of theta, what if we wanted to talk about the sine of pi over 2 minus theta, this one? Which ratio would that be?
Well, it's opposite over hypotenuse, so it's B over C.
It is B over C. But if I don't talk about pi over 2 minus theta, and instead I talk about pi, not pi,
Theta.
theta, thank you. Instead I talk about angle theta, which is down here, B over C are still a trig function related to that theta, but it's not sine anymore.
It's cosine.
It's cosine because it's adjacent. So instead of talking about B over C being the sine of pi over 2 minus theta, would it be simpler to just call it the cosine of theta?
Absolutely.
Okay, well what if I talked about the cosine of this angle? Adjacent,
Adjacent is A,
hypotenuse is,
C.
and A over C, if I define it in terms of this angle in the bottom corner,
Well, that would be a sine function.
that would be a sine.
So you're telling me that if I got sine of pi over 2 minus theta, I can throw it out and just replace it with cosine of theta?
Absolutely.
And the same thing with the sine and the cosine of pi over 2 minus theta?
Absolutely.
Is that why they're called co-function
That is
identities?
why they are called co-function and why Mrs. Cofield got to explain them to you.
Ah.
They are also called complementary because the angles add up to 90 degrees from
Almost said
geometry.
180.
That's supplementary. Okay, what if we talk about the tangent of pi over 2?
Tangent is b over a.
B over a, but if I wanted to define that in terms of this theta,
I don't know, maybe it's called the
that's
cotangent.
the cotangent of theta. Okay, what if I had the cotangent of this one?
Well, then that would be a over b.
A over b, which in terms of the other angle would be
Tangent.
tangent. Are you
Of
seeing
theta.
a little pattern here?
I see a pattern.
Okay.
I got tan and cotan.
Yep.
I got cos and non-cos. Oh, wait, sine and cosine. That's what I got.
Okay, don't let him talk anymore. Okay, how about the secant of pi over 2 minus theta?
Well, that would be hypotenuse over adjacent.
Yes, it would.
So
that would
C
be
over
C
A.
over A. But if I look at this angle in the corner,
How about cosecant?
cosecant it is.
I'm getting the pattern
You
here.
getting this now? And if, of course, I have the cosecant, do I even have to write it?
How about secant
How about
of the
secant
angle?
Of the angle. Okay? So you're going to watch for, typically, we watch for this pi over 2 minus
What if it's not pi over 2? Will it work?
These are co-functions, so
Okay,
no,
so
they
no-
work only for this. Later on, we'll talk about, where's my highlighter again? Thank you. Later on, we'll talk about if it's not a pi over 2, what to do if we are adding and subtracting. That's more identities for another day.
Yay!
All right, Mr. Lecky,
I'm odd.
you're odd.
I
Come
get the
on
odd
over.
even identities. That's what she said here. Okay, so we got odd even. Do you remember odd even functions? Yeah.
Well, parabola's even. Is that what you mean?
Pretty much, but here's the definition of an odd even
Oh, you
function.
mean proving.
When we proved odd even functions way back in, what was it, August and September? That was
Pretty
a long
close.
time ago.
So we put in a negative.
And if we got the same function out,
It was even.
it was even.
Okay?
Now on a graph paper, that meant, you were right, like a parabola, if I plug in a minus x and I plug in an x, I get the same y value. That's
Yes.
basically what it meant.
I agree.
So even functions were symmetrical about the y-axis.
Yes, they were.
And if I plugged in an opposite x,
I got an opposite y, so negative f of x. That was odd.
that would have been odd. And again, on graph paper, that would have been something that looked like this, where these points were on the opposite side of the x-axis.
And that was rotational symmetry.
Or odd symmetry. That's a long word. I
I've
like
taught
three-letter
geometry
words. Odd.
more recently than you have.
Okay. So looking at a sine function here, is a sine function odd or even?
Well, if I spin it around the origin, it is odd.
It's going to be odd. Okay, so a sine function is odd. So if I plug in a negative angle or negative radian measurement here to the sine function, I get out the opposite of the sine function of the angle.
I get a negative answer. Good.
Okay, that is our definition of an odd function.
Okay.
So cosecant is just the reciprocal of a sine, so the reciprocal is also odd. So we're going to get negative cosecant of theta.
Okay.
And this is going to become important because as we start putting functions together, or functions inside of other functions and trying to manipulate all this stuff with our identities, we can't really compare stuff or do things unless the angles are the same. So if I have a sine of negative theta and I have a sine of theta, they're not the same. But I can't relate them now with these identities. So cosine, how about a cosine function? Is a cosine function even or odd?
It's even because it flips over the y.
I'm going to write this down. This one was even, this one was odd.
Yes.
And since it's an even function, if I plug in the opposite value, I get f of x. And the f or the function in this case are just trig functions.
Okay, so if I plug in a negative cosine, that's the same as a cosine of a positive angle?
I just get cosine of the angle. And
Okay.
you can see that from the picture. If you were to plug in a negative angle, you get the same answer as a positive angle over here.
Right.
Okay? And secant's the reciprocal of cosine,
So it's also
so
positive.
it's also even, and you're going to get secant of theta.
Okay.
All right, how about tangent? Is tangent even or odd?
Well, tangent spins around the origin, so it's odd.
So what's odd?
So tangent
So-
of negative theta would be the opposite of the tangent of theta?
I mean, negative tangent theta, the opposite of that.
Okay.
And cotangent, same idea. It's also odd. We're going to get negative cotangent of theta. So what you've got to do now is you've got to put all these pieces together. Real quick, you've got them on your paper, but you have all of these identities from reciprocal identities, quotient identities, the Pythagorean identities, cofunction identities, and odd even identities. That's a lot of identities all in one day, isn't it?
It is.
So keep them handy for today, but the goal is eventually you're going to get so good at these, you're going to just use them whenever you possibly can, okay? But that's the information. We will spend our class time practicing this till we're sick of it, which may not take very long. But
Okay, so what are we practicing?
we are practicing simplifying or rewriting trig expressions and proving them as we get to that point in the last couple of examples.
Okay.
Okay, we're going to prove identities, which again are two things that are equal on both sides.
So what does simplify mean?
Simplify. Final answer should be simpler than the original one.
Okay.
We would prefer to have one trig function in our answer, and we would prefer to have no fractions. So instead of leaving it as 1 over sine, we would write that as cosecant, and using an identity to do that. Now,
Okay.
how are we going to do this? We're just going to have to practice.
Okay.
The more we do, the better we're going to get. We've got some strategies for you. You might want to keep them handy, and we're going to show you one of each of these over the next few minutes, right?
Yeah, 3 strategies today.
3 of them today?
Yep.
And then the rest of them next time.
Yep, there's about 6 strategies. So rather than overload you all at once, we're just going to do 3 today.
All right.
Okay.
Mrs.
here's
Schofield's
the-
up for number 1.
I'm ready. This is the easiest strategy there is. When in doubt, change everything to sines and cosines. He has to have his answers to help me out. Okay? When in doubt, go back to where you started, which was learning sine and cosine. Okay, so the first example that we have is a cotangent of theta times a secant of theta times a sine of theta. That can easily be simplified. Cotangent is really what?
Cosine over sine.
Cosine of the theta.
And
Don't forget the
don't
theta.
forget the theta. My bad.
Over the sine of theta. We don't say it, but you should be writing it. Okay? What is a secant again?
1 over cosine of theta.
1 over a cosine of a theta.
Of a
And remember
theta.
these were times. And a sine is already a sine. So I'm just going to do that. And I'm
Can
going
we
to put
put
it
it
over 1 so I have fractions.
Yay.
Okay, do you remember a little thing in fractions called canceling?
They
Cancel.
don't. I'm telling you right now.
Cancel. You can only cancel when there's multiplication. If you see a plus or minus, don't you dare cancel. So we say it's okay. And so this sign would cancel with that sign. So what just happened?
Everything made a 1.
Everything made a 1. That whole expression is simply equal to 1. Ta-da!
1's a lot easier to use than that whole nasty thing.
It sure is. Okay, oops, I'm going backwards. Oh, I went way backwards. Hold please. There we go. All right, let's try strategy number 2. We're going to use Pythagorean identities. And again, Pythagorean has something squared in it. So watch for things that are squared. That's really what that says. You can't tell.
The hardest
Okay.
part of this is just recognizing when to use them.
And co-functions we already mentioned you were going to talk about when we have the co. That's where we watch for pi over 2 minus the theta. Okay, so keep your eye out for those 2 things. All right, so we have sine squared theta plus cosine of pi over 2 minus theta minus 1 plus cosine squared. Blah! What a mess. All right, first thing I see is I see right here that I have a pi over 2 minus theta. And from a couple slides ago, we figured out that the cosine of pi over 2 minus theta was
Sine of theta.
the sine of theta. So all I did is I changed that. Now, I'm going to keep everything else exactly the same. Even though your brain goes pretty fast on some of these original ones, you will confuse everybody. So try to get in the habit of rewriting everything, just like when you were solving equations.
This is like Algebra 1. Show every step,
Show
do one thing at a time.
Every step, one thing at a time. Because if we skip a whole bunch of steps, you're going to go, wait, what happened? Okay? All right, second step.
That's what Mrs. Schofield looks like when she's grading your quiz.
Pretty much. Okay, so now, recognize, this is all addition and subtraction. I can do it in any order I want. So if I have the sine squared here, and I have a cosine squared there, the Pythagorean says that that's equal to?
1!
It is 1. So I'm going to keep the 1, which replaces those 2, and I'm going to copy down my sine of theta, my minus of 1. Oh, but wait! Algebra.
There's more.
Arithmetic. What is 1? Oh, I need a new color.
1 minus 1.
1 minus 1.
0.
See ya. Our answer for this big, nasty, long expression, it is simply the sine of theta. Look how much prettier that is. Isn't
It's
it
pretty.
gorgeous? It's gorgeous.
It's party.
Okay, third strategy. I'm going to roll. I'll just keep going.
Keep
One of the
on
things you want to
going.
watch out for is factoring the greatest common factor. Is there anything in common? We've got cosine of theta minus cosine of theta times, this is a times, the sine of theta. My times didn't line up, but there we go. Okay, they both have a cosine of theta in them. So, backwards of distributive property, let's take our cosine of theta out. Now, matter can be neither created nor destroyed. Same thing with trig. Same thing with math, okay? So, whatever this cosine is, I need to be able to distribute it and get that original expression back again, okay? So cosine of theta times 1 is going to make my cosine of theta. I have a minus. If I already divided out this cosine of theta, what's left?
Sine squared of theta.
Very good. Now, does that look like we're done? Let's think about our rules. We wanted to have one trig function if possible. Don't have one trig function. Maybe there's something else we could do here. I see a squared. Is that ringing a bell?
Pythagorean ones.
Oh, wait.
But it doesn't look perfect.
Cosine squared of theta. Notice I'm going off to the side now because I'm thinking, and I'm trying to show you my thinking. Plus the sine squared of theta.
I wish every woman would show me how she's thinking.
But we change our mind every 2 minutes. So
It's
can't
too
do
much
that.
to write down.
Okay, so we have 1 minus the sine squared. Is there any way that I can manipulate this to make it 1 minus the sine squared?
How about if you keep subtracting sine squared for both sides?
If I do that. See, he writes faster than I do, so I want to make sure I got a head start. So do you agree that the cosine squared of theta is still 1 minus the sine squared of theta? This is still the Pythagorean. We just rearranged it a little bit.
So it was true to begin with, and if we rearrange it, it's still true?
As long as we follow the rules of algebra when we rearrange
Fair
it.
enough. Rules.
I know. Okay, so the green part is my new part, my new cosine squared. I already had a cosine. Any guesses what a cosine times a cosine squared is?
Is it cosine cubed?
It is, and it has a theta on it. So it's a cosine cubed of theta. And even though it's cubed, it's one trig function, so it's much easier than the other ones.
Is everything going to come out to one trig function?
No, because our first example came out to the number 1.
Oh, that's true.
Okay, but we are going to try as best we can to get it all down to one trig function. Okay, might have numbers mixed in there, 2 plus something. Okay, we're just going to practice a ton of them. Okay, this is even odd, so you're up.
Oh, right.
You are comfortable.
Somehow I get the odd ones all the time. Okay, so we're at even odd here. We have sine of minus x and cosecant of x. And as I said earlier, and I don't know if it made any sense then, but maybe it will now.
Say it again.
I cannot combine any of these trig functions because really I'm looking at 2 different angles here. I have a minus x and an x. Those
It's like they're
the same.
not like terms.
Exactly. And you can't combine like terms and you can't do anything with these functions unless you can rewrite them.
Okay.
So using the fact that our odd identity for sine function, sine of negative x, was simply the opposite of sine of x.
Yes.
And then I'm multiplying that by the cosecant that was there originally. And then I can work from there, because now I have exactly the same angle in both terms.
Now, does it matter if we put those parentheses on the x or not?
They don't have to be
Okay.
there.
So if they're there, great. If not, that's the same thing.
I like them, but you don't have to put them there. Nope. All right, so I'm going to change this now into, what is cosecant?
1 over the sine.
1 over sine. That's one of our strategies, is to change it into sines and cosines, because everything can be written with a sine or a cosine. And I have sine of x times 1 over sine of x.
That's
What
1.
happens? These
Those are
cancel?
reciprocals.
So what is my final answer?
Negative 1, because there was
I've got
one
a negative sign here, so I've got this whole mess, turns out to be negative 1.
Very nice.
All right, piece of cake.
So that's all we're doing is simplifying?
If there's just an expression, it says simplify, you go as far as you can, and you stop whenever you can. We're, like we said, we're trying to get down to 1 term.
So what else are we going to do?
We're going to prove some identities.
Proving. I don't like proofs, blah.
Did you hear anything? I'm just going to ignore all the whining. Okay. Proving. Yes, they are proofs. And there's this wonderful paragraph about how they relate to geometry proofs and how we know you love them. They do love them.
Actually, these are easier than geometry proofs.
Much.
Because you don't have 2 columns.
In geometry, you had a statement and you had a reason and you had to write things down and you had to match this reason to that statement and so forth.
Yep, we don't do that. But we do still follow a logical order. Yeah.
This is my favorite sentence. Sufficiently obvious enough to require no additional justifications.
That's what your book says.
You know what that means?
What does that mean?
Do 1 step at a time.
Okay.
Don't skip steps, okay?
And why do we do 1 step at a time? So you can see
Because it needs to be sufficiently obvious, and
Yeah.
we're not that bright.
where you, yeah. It needs to be blatantly clear to us what you did.
Child of 5 has to be able to figure it out. All right, maybe not, but you understand. So we're going to do the same things. But instead of letting you just roam the planet trying to figure out how to simplify it until you get down to a single term, we're going to tell you where to go.
You gonna give us the answer?
We're going to give you the answer.
Awesome.
We gave it to you in geometry.
Yeah, I guess we didn't realize that.
Love
did you?
that too.
Okay.
So here's the deal. We're saying that cotangent squared of theta is equal to cosecant theta times cotangent theta over secant of theta. They look equal, don't they?
If you say so, I think you're.
We have to prove this. Now, what we have to do is prove it.
If you say so.
Now, which side do you think we should prove?
We should start with the yucky side.
Start with the yucky side. And yucky, by definition, is more than 1 term, okay?
More complicated.
So we're going to start, and you should probably write this down just so we know which side. We're going to start with the right side. Is that okay?
Okay.
And we're going to say that cosecant of theta times cotangent of theta over secant theta. And we're going to do stuff to it, just like we did before, but now we know we're trying to make it equal cotangent squared.
Okay, so it's just like before, but we know the answer.
Exactly. So now we're just going to work on this side just like we did the earlier problems.
Okay.
What was our first strategy from before?
Change everything to sine and cosine.
So we're going to take cosecant and write that as 1 over sine of theta.
Okay.
And cotangent's going to be cosine of theta over sine of theta.
And secant's going to be 1 over the
Yep.
cosine?
And now we're dividing by 1 over cosine of theta.
Okay, it's kind of messier here.
It got uglier real quick, didn't it?
Okay,
How do we fix this? Well, this means what?
divided.
Dividing, and we're dividing by this fraction, yes?
Yes, we are. So instead, we copy dot flip,
If you want to say that, fine.
multiply by the reciprocal.
That sounds better to me.
Okay.
All right. So we have the top, which is 1 over sine of theta times cosine theta over sine of theta. But instead of dividing by the fraction, we're going to multiply by the reciprocal of 1 over cosine of theta, which is cosine of theta over 1.
Okay.
Now it's a little nicer because it's just a bunch of fractions.
Okay, multiply straight across the top.
So we have 1 times cosine is
Cosine squared of theta.
cosine squared of theta over
Sine squared of theta.
sine times 1 is sine squared of theta. And what is cosine squared times divided by sine squared?
Cotangent.
It
So
is
cotangent squared.
squared of theta.
Oh wait, that was the other side.
And that's what we really wanted.
We did it.
And we're happy, and we move on.
Very cool. So it's my turn. I
Your
gotta
turn.
try one.
Okay, you
Let me see
try
if I
it.
can do it. Okay, so we have to start with the most complicated side and get to the easier side. And in this case, the most complicated side is going to have the fraction. And I want to try to make that big mess, secant of negative theta over 1 plus tangent squared theta equal the cosine of x. Okay, so you would like me to indicate that I'm starting on the left side?
Yes,
Okay.
I would like you to indicate.
Going to start on the left side. So we've got the secant of negative x over 1 plus the tangent squared of x. Okay. Well, I remember a minute ago that I tan in a second. So if I have 1 plus tangent squared, that's really
Secant squared,
Okay,
or
so-
second squared.
second squared. So I don't really tan, I burn, but that's okay. I'll go with it. So this is secant squared of x. Now, a minute ago you said that we had to have the same input, if you will, right here. Well, I have a negative x and a positive x. I must be missing something. Okay, so let me think. I have a negative. A secant is the reciprocal of a cosine, and a cosine was even.
Even.
So,
When you plug in the negative to an even function, you get the same thing.
so the secant of negative x must be the same as the secant of x.
Uh-huh.
Oh, and that's over a secant squared.
Yep.
So notice this time you do not have to go to sines and cosines, because now I have secant of x and secant of x. In fact, I have a secant divided by a secant squared.
So
That
do
would
one of
be-
them cancel?
That would be like me having a over a squared.
That's
Wouldn't that just be 1 over a squared, or 1 over a,
1
rather?
over a.
So 1 over the secant
1 over the secant.
of x, but it's still a fraction.
Well, look at what we want to get when we're done.
Oh, okay, so I was trying to get to cosine. Wait a minute, 1 over secant, the reciprocal of that is,
Cosine.
we're done. I did it.
Do we have to write cosine at the end there?
Draw some smiley faces.
Yes. High fives, balloons, and streamers.
Yes, you need to write down the right-hand side because you need to show us that you got to the
So
other
you just
side.
have to work one side until you get the other, then high five somebody and move on, right?
That's it. In fact, that's it for our video. We're done. So
That'll do it.
here's what you learned. You learned what the identities are. You learned that you can use them to simplify and you can use them to prove. We learned 3 strategies to do that, and we'll learn 3 more next video.
Start studying these ones now.
Memorize
These
them
ones?
in your brain. These ones. Our math teacher.